Okay. So the first one's just say to simplify the expression. So these are really just combining like the exponents and stuff. Number 4, we've got e to the negative 2 times e to the 6. So these are going to work the same way as when we had like, x squared times x cubed, and we said that was x to the 5th where we added the exponents. The rules of exponents that we've had previously still apply. So, what? Yep, e to the 4th. 6. In parentheses, 2e to the negative 2, only the e's to the negative 2, and then all of that is raised to the negative 4. So yeah, I would probably distribute the negative 4 like exponent first to get 2 to the negative 4, and then that was going to give me e to the positive 8. Multiply the exponents there. Then what do I need to do?
Take the negative 4 to the bottom.
Yep, I need to move this to the bottom. So this would be e to the 8th over 2 to the 4th. And what's 2 to the 4th? 16. So e to the 8 over 16. Uh, 10. E to the x times 5e, sorry, to the x plus 3. What's different about this one? We have an exponent that's x plus 3. These also, one is 5e and one's just e to the x, right? But really, if we wanted to think about this, this is just 5 times e to the x times e to the x plus 3, right? So it's not actually changing the base, right? Because the x plus 3 is only on the e. So we're still going to add the exponents. So this is going to be 5 times e to the x plus 3. Okay, so it's just adding basically a variable exponent now. And so then our answer would be 5e to the 2x plus 3. So we still, just like our normal rules with like adding like terms, it still applies even though they're in the exponent. (14) 6e to the 4x, and again the 4x is only on the e, over 8e. Any ideas what I should do with this one?
Could you reduce it?
That would be what I would do first. What would I get if I reduce it? 3 over 4. And then what about this e to the 4x over e?
Would the e on the bottom cancel and then it would be 3x? No.
If this was an x, like raised to the x, then we could do that. How do I move something?
Put it
Make it a negative.
Yeah, put it where it ain't, change the sign. In this case, make it a negative. So this would become e to the 4x minus 1 because this one is just raised to the 1. So to move it, we just have to take it and make it negative. And we can't combine those because those aren't like terms. So we just write it, literally, it's e to the 4x minus 1. And if you wanted to write it like 3e to the 4x minus 1 all over 4 like that, that's fine too. We just usually end up writing it like this. The book's going to write it like this, but I usually write it like this. Let's see. The next ones are the ones where you're going to need your calculator. So number 20, e to the negative 3/4. So we're actually solving what this is equal to. We're not like simplifying it. So what you're going to do, I can get this to show up. Over on the, where is it? Left-hand side, you're going to see the word log, and then you're going to see ln. Above ln is e to the x. So to get that, you have to hit second ln, and that's going to bring up e to the power.
Maybe turn on the calculator first.
So you have e to this. Now, when we do the negative, we have to use this negative here that's at the bottom of the calculator, not the minus sign that's on the right. So negative 3 divided by 4. And we'll round to 3 decimal places, so 0.472. Whoa. If we had something like number 30 instead, where it's 0.4 e to the 4.1, then I'm going to type in my 0.4, then I'm going to hit second ln to bring up my e to the x, and then I'll put in 4.1 there for the exponent. Is everybody okay with typing in e? It's working. Okay. So then I get 24.136.
I like these ones a lot.
All right, we're getting into growth or decay now, because I trust we're okay on those calculator ones. All right, so this is where we're going to be going back to, we're going to be going back to, where is it? Right here, this form, a e to the rx. So if a, well, in both cases, a has to be greater than 0. But if r is greater than 0, then it's an exponential growth. If r is less than 0, it is a decay function. So we're just stating if it's growth or decay. Okay, not actually graphing them on these. So 32 f of x is equal to 1/3 e to the 4x. So determining growth or decay, first of all, I'm going to look, a is greater than 0. Okay, basically just means that the number in front can't be a negative number. And then r is the number that's in front of x, so r is also greater than 0. So that means that it is a growth problem, or growth function. (34) f of x is equal to 3/5 e to the x. Is a greater than 0?
Yes.
Yep, a is greater than 0. What about r?
Yes,
Why?
because it's just 1.
Yep. So there's just an imaginary 1 here, which is greater than 0, so this is also growth. Uh, 38. F of x is equal to 4e to the negative 2x. Is a greater than 0? What about r?
No.
Nope, r is less than 0 because it's negative 2. So then this is decay. All right, now word problem 58. It's a word problem, but it's really not. Yeah, I don't know. You deposit $800 in an account that pays 2.65% annual interest. Compounded continuously. What is the balance bless you after 12.5 years? All right, so we're going to be using our A equals PE to the RT formula. So if you have ever put money into a savings account or something, right, then probably more than likely it's like once a quarter. Some banks are once a month. But you'll get paid some amount of interest based on what's in your bank account. Okay? So this is one that's compounded continuously, so this is a little bit different. The stuff that we skipped in the last section that we'll probably come back to, but not today, but those ones are how to find it when your interest is compounded monthly, or like quarterly. It can go to like weekly and stuff like that, but most banks aren't doing that. But anyways, this is if it's compounded continuously. So our formula is A equals PE to the RT. So I'm going to label what each of these things would be out of here. So this $800 is going to be P. That's the principal amount that we start with. E is obviously just the number, so we don't need anything with that. Now, R is technically this 2.65%. However, that is not how we write it in our equation. It gets written as a decimal. So how would I write 2.65% as a decimal? Yep, so I'm going to make a note over here. This is 0.0265. This is what's actually going to get plugged into my formula. And then T is the number of years. So this value, 12.5, is T. And so A is what we're ultimately solving for, is how much money is there going to be at the end of that amount of time. And this is obviously assuming you don't ever take money out of it. This is like, if I just keep leaving money in here, what's happening? So A equals 800 E to the 0.0265 times 12.5. So you're going to type this in your calculator, just like we did with the other ones. You just now are typing in a little bit more. So you'll hit 800 and then E, and then when you get up to the top, just make sure you hit the multiplication symbol between the two numbers, or put parentheses around everything.
Interesting.
And then this is money. How many decimal places does money get? 2. So $1,114.17 because it rounds up. So what you'll see when we end up coming back and hitting some of these other, like compounded monthly and whatever and so on and so forth, the slightly different formula. But what you'll find with those is that you want to find a bank to put your money in that has a high interest rate. So typically your major banks like your Wells Fargo's and stuff like that are going to have a lower interest rate, whereas a credit union typically has a higher interest rate. So if you're putting money in savings, that's something that you can start doing now, and I strongly encourage. It's my little plug. Start saving money now. But find a bank that you can put it in that is going to give you basically the biggest return on your investment. Put money there and leave it and let it just keep growing. That's my little plug. All right, questions about this? All right, problems 5, 9, 11. In 19 through 30, you can pick 2. It's the calculator ones. Pick your 2 favorite ones. I don't care. Can't be 2 that we did, but any other 2 is fine. And then 33, 35, and wait. No, 33 and 37. Sorry, I can't read my paper. And then 57. There we go. I was blending my 37 and 57 together and making it 35. So 57 will be a word problem just like the one we just did. Just the person and stuff is different.